So, a chemical equation can be either a word equation that uses the names of molecules or a symbol equation that uses the corresponding symbols and formulae. Chemical equations have three parts. The reactants, which are the molecules reacting. The products are the molecules that are formed from the reaction, and the arrow, which means reacts to make, and shows that the reactants are turning into the products. To write this word equation as a symbol equation, we need to know the symbols for each molecule. I'll give you 5 seconds to guess the symbol for each molecule. Carbon dioxide is CO2. Carbon and oxygen atoms bonded covalently in the ratio 1:2. Reactant 2 water. This symbol is H2O. Another simple covalent molecule with hydrogen and oxygen atoms in the ratio 2:1. Product 1. Glucose. This is more complex, but glucose is C6H12O6. Final product, oxygen. The symbol is simply O2. Oxygen is another simple covalent compound. Now just replace the words with these symbols and you get a symbol equation. But this looks a bit different to the symbol equation I showed you at the start. That's because symbol equations need to be balanced. It's due to a law called the conservation of mass, which states that mass cannot be created or destroyed. In other terms, the mass of the reactants is equal to the mass of the products. In our photosynthesis unbalanced symbol equation, we have 1 carbon atom in the reactants and 6 on the products. The mass is already different on both sides. 2 hydrogens on the reactants and 12 hydrogens on the products. We need to balance this symbol equation. Let's balance this equation. The production of ammonia in H3. First, I wrote out the number of each atoms in each compounds. N2 is NN and so on. As you can see, there is only 1 N on the products and 2 on the reactants. So as we need 2 on the products, let's add another ammonia molecule. So we now have the same amount of nitrogen atoms on both sides. Hydrogen has 2 atoms on the reactants and 6 on the products. If you're good at maths, you'll notice that we need a total of 3 H2 molecules on the reactants to balance the 6 hydrogen atoms on the product side. Final step, we just count the amount of each molecule and add that number at the start. Remember, there's no changing the small number. So we've got still 1 N2 molecule, 3 H2 molecules, and 2 NH3 molecules. Job done. Thanks for watching. Please subscribe for your benefit, and so we can hit 1,000 subscribers by the end of the year.